strap with a handle and a couple of bosses that's used to secure items in a rack. So it's a perfect item to use for the Flex feature. You can access the Flex feature through the Insert menu, Features, Flex. The Flex feature has 4 major modes. You can bend parts with it, twist parts, taper parts, or stretch parts. Let's select this part and how we want it to bend. The first thing we need to do is position the trim planes. We can pull these back and pull this one back to just inside the bosses, and then position the bend axis to allow the part to bend. Next, we can apply either a bend angle or a bend radius. And as the bend gets larger, you can see the part flexing. You can also see the radius as the angle changes. This feature can take a long time to process, but notice what it's done is it added edges as if it cut the part and then just bent the area in between, and everything else is straight or flat or round or just the way it was before. This isn't the kind of feature that you should use to design parts, but it's probably most appropriately used to show a part in an as-used position. If you want to design a part that's bent like this, then you should use regular features and design a curved part, rather than depending on the Flex feature, because the Flex feature has a tendency to be rather approximate. You won't get a lot of precision out of the Flex feature. Let's revisit the Flex feature and see if we can create a different kind of flex. Twist is another one that you can use. And in this case, we can use the same trim planes and just change the angles slightly. It's that the part that's flexing or twisting is the part in between the trim planes. Again, this is great for illustration purposes or a looks-like model, but you wouldn't want to use this as a primary design tool. If you want to both twist and flex, you would need to apply 2 separate features. I would do the twist first and then the flex. So let's insert, feature, flex, and bend using trim planes. If we had keyed in actual numbers for the trim planes, then it would be repeatable, but I'm just doing this by eye. And let's move this back. Let's go 180 on this and accept it. So in this case, we've got the part twisted and then bent. This does not represent what actually happened to the part if you were to apply forces to it. It just is a geometrical process to overall affect the shape of the entire part. So you wouldn't want to use flex to simulate actual bending. Again, it's just a good visual tool to show flexible parts in flexed states. While we're here, let's suppress these 2 flex features and take a look at the deform feature. Deform is a similar type of feature where you wouldn't really want to design with it, but showing parts in a deformed state. So let's take a look at that. That's again accessible through the Insert menu, Features, Deform. There are 3 ways to use this. You can have a point deform, as if you were pushing into a plastic part with a pencil. There's a curve to curve, which I find the most useful. This is where you can create a sketch curve and match an edge on the model to the sketch curve. And then there's the surface push, which allows you to use a tool to press into the part. It's a particularly good way of creating shapes or a very intuitive way to get an intentional result. If you're looking to really use one body to push into another, you might be better with the indent tool. Let's do an example with the curve to curve. I'll have to get out of this while I create a sketch curve to deform the model. And what I'll do is create this edge of the handle, but pushed over a few inches. So let's use the front plane, control drag, and let's put that just 2.5 inches away. Over here, I'm going to open a sketch and grab the edge and use convert entities to copy it. So it's copied onto a new plane. Now I'll use insert, features, deform, and take the initial curve, which is the curve from the part, and the target curve, which is the new sketch. Transforms the whole body, but that's not what I want. So I'm going to fix some faces. Let's fix this face and this face. And then we can set a couple of options on the shape. You can make the part not very stiff or very stiff. I think for a rubber part, the not very stiff option would be the best. And the shape accuracy, you can slide to create a result. The slider allows you to control how much the body wants to move. If it wants to stay where it is, or if it wants to move to the new location, or if it's kind of a neutral. And so with this, we'll say, okay. Now again, this deform feature is not the kind of thing that you're going to get a lot of accuracy out of. Notice that the formerly circular knobs on here are now pretty ovalized. And I'd be willing to bet that any other dimension on here that you had counted on before is no longer what it was. But it's a good visualization tool. That's about as far as I'd take it.